Well, hello everyone. Welcome to week number 3. Hope everyone's doing well. Enjoyed as much of Easter as you possibly could. And we're going to continue on here in science. So if you remember last week, we had a quiz. I'm going to move my cursor so it's not like right in my face. But we had a quiz and it was only 10 questions. So if you missed it, take it. Over food chains and food webs. So looking at all of this, what does it mean? Well, I think with everything that's going on, even in the world currently right now, we can link it back to a lot of stuff. In everything we do, there's only so much energy, right? So what does a balanced ecosystem look like? The next thing we're going to talk about here is called carrying capacity. Think about it for a second. What do you think carrying capacity actually is, or what does it mean? Well, carrying capacity is the number of organisms an environment can hold. So, for example, if you're thinking about this, it can be anything from micro ecosystems to macro. Depends what you're looking at. For example, cheetahs aren't found here. You'd have to go in their habitat, in their environment, and go, what would make a cheetah's carrying capacity? That means how many organisms can that hold? You know, every year we go hunting for deer. They have a carrying capacity. Now, if we didn't hunt, we'd have issues. Okay, if there's too many deer, what happens? They overgraze. They eat too many producers then. That throws the whole balance of that ecosystem off. So once that organism reaches the carrying capacity, a few different options can happen. And that's what we're going to discuss today. So, for example, I'm going to pull up I'm not going to go to that yet. I think it's this one. Yes. So you can see here, this is kind of dark. I'm going to pull it full. So here would be the carrying capacity. The carrying capacity, think of, for example, what do organisms need? What's going to hinder the size of that group? Well, if you have food, and you have water, and you have shelter, and you have those unlimited sources, your population can keep going up, 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 up. Now, what happens if you overshoot it? Now, you see this? This is called exponential growth. Taking off, the population skyrocketing up. This dotted line is going to represent what we call the carrying capacity. If you overshoot the carrying capacity and you're operating up here, suddenly it's like, whoa, the environment goes, hey, we don't have enough resources for you. We're going to knock you back down to reality. Either a disease like a virus, could be a bacteria, starvation, all these different things. Even when you look at overcrowding of stuff, that's when you get the viruses that spread from animal to animal. Now, and what can happen is you get up and you go below it. And then you go back up and you go below it. And you go back up and it's called a J-shaped curve. So as you go, your population can hover around what we call the carrying capacity. Or you could skyrocket above it and then almost go to extinction. Or you go above it and you kind of hover right below it. Those are kind of the options that we have of carrying capacity. Well, we're going to look at a carrying capacity graph here of something. So let's look at the population growth of us. So if we go back as far in basically recorded history of what we can roughly guess what the total population is, we're going to look at some different time frames. So if you look at, this is about 2 to 5 million years ago. Okay? You can see we didn't even hit 1 billion people. Okay? Now, as we go through time here, our carrying capacity our population doesn't skyrocket. It generally just kind of hovers right here. Now, there's only been one time in recorded history that we've seen a big overall global population actually go down. And that was due to the Black Plague, or Black Death, or the plague, or whatever you want to call Now, after that, we see a huge increase here. Why? What would cause us to just increase what I would call an exponential growth? What's going on here? So, well, that's a great question. That's a question that you are going to have to answer later on. So, along with that is what I want us to go to is I'm going to show you an example of a population clock. All right, so this is the website that we're going to work with. It's called worldpopulationhistory.org. It's a really, really neat website. The first thing I'm actually going to do is I'm going to we're going to watch it. And we're going to
An environment.
Sorry, we're going to watch this movie. And with the movie, it's a lot of informative stuff here. But just watch it and just listen.
Is a system of living things. The Earth is our environment. The capacity of our environment to provide space, to produce food, and to supply energy are all limited. Humans thrive on less than 17% of the Earth's surface, and only about 4% will grow crops. We depend on these limited resources for our survival, yet we are increasing our population as if they were infinite. This fact is at the core of our environmental problems. On this map, we'll show population growth from the year 1 CE to the present, and project our growth into the year 2050.
So, for example here, 1 CE would be 220 years ago. Or 2020 years ago. So we're just going back to that till to present, and then beyond present we're going to go.
Population concentrations will be indicated by dots, each of which will represent 1 million people. In areas where people are spread out and don't live in concentrations of 1 million, dots are placed in the middle of their approximate range. Historical references will be provided by images and text at the bottom of the screen.
So if you remember, each cluster here, the yellow represents 1 million people in that area. Not necessarily like here, if you go in America, it's not like there's 1 million people here, it's just in this spread out area. And as we go through this, of course, you can see how dots are being added. You can see how they kind of pop up. So we're at 300, here's the golden age of India, here's India. And down here you'll see major events that happen in the Earth's history. Mayan Empire. There's a few adding, so about 1400 years ago right now. You can see our population hasn't changed a lot, it's been relatively the same. The Vikings, you see a few pop up, or 1100 years ago about. Of course, this number increasing is representing the years. And now, we're less than 1,000 years ago, and we're getting there. Mongols invaded China. You can see it kind of how that took a hit. Black Death, look up here. You'll see one time and where population has decreased. We haven't even hit America yet. Okay, 1700s. I'll see if I can get this down here and kind of match up. There we go. Now look at the numbers increase. 1900s. And look how it's taking off.
Our population is expected to grow to 10 billion by the end of this century. Yet the Earth's size remains the same. Slowing human population growth and lowering our use of natural resources are key to reducing the impact we have on the planet. Through the decisions we make about our lifestyles, our numbers, and our consumption, we can all help preserve the health and beauty of our home.
Okay, so I want to kind of show you how to work this website because you're going to be answering some questions on it. Now, when you look at that and you think about those last, looking at how the end of this thing is gone, I mean, we went from the first time we hit a billion was the 1800s, and now we're pushing, we got a little ways yet, but 8 billion people on the planet. And yeah, that ends up being a problem because what is our carrying capacity? The environment we're working with is the Earth. And what happens when we overpopulate? Well, we've seen in other organisms. If there's too many, something has to give. Some people say we're already hitting the carrying capacity, and that's why a large portion of the Earth goes to bed hungry. That's why we do have people die of starvation, things like that. Some people will say what's happening with coronavirus is carrying capacity. We have too many people on the planet. And what happens when you pack people in very closely together? A virus can spread. Now, we've seen this in other organisms. Now, how this website works is if you go up here, there's things that says watch video, explore map and timeline, how to use it, population readings, tools, don't worry about resources, and all that. So, for example, let's explore the map and timeline. If I click that, we've already watched the video. So if I explore the map, you can see here it can break down in recorded history. So if I move this from year 1 to whatever, now you can see the world population go up as I slide through. Now, why is this going to be important? Because this is going to be important with when you are answering questions here for me, basically. So just make sure you understand how this works. Your different themes here is you can choose. If you just want health, you can see it eliminates the health, stuff like that. Overlays, we can see human land use, how that's changed over time with our population, of course. And you can compare and contrast those. You can see life expectancy, how that's changed, map features, population, dots, and then milestones. So I'm going to be asking you some questions, basically of just kind of mess around with this world population clock. And that's one thing I want you to think of as you're working on this is carrying capacity. Sometimes I think we as humans think we're above it. Technology will keep us ahead of it, but maybe not. And it is something to think about. So your assignment will be on Google Classroom right underneath this. And other than that, have a great day. And your next assignment will be the following week, Monday. All right. See ya.